Good day to you from Chem Help ASAP. In this video, we will discuss X-ray crystallography, which can be fantastically helpful for lead optimization. Upon completion of this video, students will be able to describe X-ray crystallography, explain the value of cocrystals for lead optimization, and visualize drug target cocrystals from the protein data bank, the PDB. X-ray crystallography is a method for determining protein structure. In X-ray crystallography, a protein is crystallized from solution. X-rays are passed through the crystal and scattered as a result. The pattern of the scattering can be used to determine the structural features of the protein. With a high enough quality crystal, structural features down to the atomic level are discernible. Knowing the structural features of a protein, the target protein, is exceptionally useful for the drug discovery team. Even more useful than a crystal of the target protein is a cocrystal. A cocrystal can form when the target protein is crystallized from a solution that also contains the ligand that binds to the protein. With the ligand, which could be a hit or lead, held in the active site or binding pocket, researchers can visualize atomic level detail of target-ligand interactions. With a cocrystal, researchers can identify the pharmacophore of a hit or lead, steric clashes that might be reducing potency, and opportunities for additional substitutions that may improve binding. Let's see an example of a cocrystal. Here is a cocrystal from the protein data bank. Entry 1XBB. This is the cocrystal of part of a protein, part of a tyrosine kinase, with a ligand, an anti-tumor drug called imatinib or Gleevec. Only the protein is clear in this view. Let's change to a different view and highlight the target ligand interactions. Here are just the key amino acids in the target protein, mostly in white, and the structure of imatinib in gray. All the key interactions between the target and ligand are indicated with these dotted lines. We can turn up the opacity of the protein, the target protein, to better highlight the shape of the binding pocket. We can see exactly how the drug fits into the pocket. We can also make some predictions on where more groups might be added to further improve binding. Maybe another methyl group over here could help binding. Hopefully you can see how incredibly informative and helpful this type of structural information could be in guiding the drug discovery group. X-ray crystallographic structures of a target, and especially of cocrystals, are a great help during lead optimization, specifically for on-target potency. X-ray structures are less directly relevant for optimizing ADME, PK, and safety properties. While I have emphasized the use of crystal structures in lead optimization, X-ray structures can be used during screening as well. An X-ray structure model can be paired with docking software for something called an in silico screening campaign. The software uses the X-ray structure to predict the binding of library members. Predicted actives must be validated experimentally, but in silico screening can be a quick and efficient way to identify promising molecules. We discussed X-ray crystallography as well as the use of cocrystals, specifically in the context of lead optimization. We also visualized a cocrystal of imatinib and a tyrosine kinase from the protein data bank. Thank you for watching this video. Your attention is greatly appreciated. If you have any unanswered questions, please ask them in the comments section below the video. Take care.